We live in a world
of patterns.
Hello everyone! Welcome to our vlog! Today we will tackle about the natural orders.
We live in a universe of patterns such as stars, seasons, and snowflakes. These patterns are not just beautiful but also serve as the clues to the rules that govern natural processes. German astronomer Johannes Kepler, in his book The Six-Cornered Snowflakes, argued that snowflakes are made by packing tiny identical units together. This was long before the theory that matter is made of atoms was widely accepted. Rainbows and lunar halos also provide information about the scattering of light and the shape of ice crystals. Mathematics is as beautiful to nature as Sherlock Holmes is an evidence that it can be applied to ideas rather than things.
Patterns play an important role in understanding the world around us. Many natural phenomena follow specific numerical sequences that are repeated over time. For example, the Moon completes one orbit around the Earth in exactly 28 days and the Earth orbits the Sun in roughly 365 days per year.
Flowers generally exhibit specific patterns that involves the arrangement of petals in spiral and whorls following the Fibonacci sequence. Even animal appendages exhibit repetitive arrangements,
such as the limbs of starfish being organized into multiples of 7, which makes for efficient movement through water. Numerological approaches towards identifying patterns can lead to misinterpretations and confusion. Furthermore, recognizing patterns helps humans to better understand the universe and gain insights into the underlying laws of physics.
Numerological observations are more significant. This numerical pattern was one of the key steps toward Isaac Newton's theory of gravity, which has explained all sorts of puzzles about the motion of stars and planets. In fact, there's a book called Nature's Numbers and Shapes. A general shape is a collection of dots and can be represented as a list of pairs of numbers. For example, the rainbow is a collection of circles, one for each color. There are also wave patterns on land. The simplest pattern is the transverse dots, which is like ocean waves in parallel straight rows at the right angles to the prevailing wind direction.
Talking of ripples, the flow of fluids provides an inexhaustible supply of patterns. There are swirling spiral whirlpools and tiny vortices. There is apparently random floating, turbulent flow, one of the great enigmas of mathematics and physics. Sometimes the road themselves becomes wavy, in which case they are called Barkanoid ridges. Sometimes they up into innumerable shield-shaped Barkan dunes. If form becomes possible, cluster of shaped dunes can form, each having several irregular arms radiating from a central peak.
Finally, there is another category of natural pattern, one that has captured human imaginations only very recently, but dramatically. This comprises patterns that we only just learned recognize patterns that exist where we thought everything was random and formless.
For example, think about the shape of clouds. Meteorologists classify clouds into several different morphological groups: cirrus, stratus, cumulus, and so on. But these are very general types of form, not recognizable geometric shapes of a conventional mathematical kinds. Clouds can be wispy, formless, and fuzzy clumps. Basically, you can tell what size a cloud is by just looking at it. Now, let's try to look at an elephant. You can tell roughly how big it is by just looking at an elephant. But clouds are not like that.
We could play it with many nature shapes including mountains, rivers, networks, trees, and every possible way that matter is distributed throughout the entire universe. In term made famous by the mathematician Benoit Mendelbrot, they are all fractals.
Our newfound understanding of nature's secret regularities is being used to steer artificial satellites to new destinations with far less fuel than anybody had thought possible. To help avoid wear on the wheels of locomotives and other rolling stock, to improve the effectiveness of heart pacemakers, to manage forests and fisheries, even to make more efficient dishwashers.
But most importantly, it is giving us a deeper vision of the universe in which we live and of our own place in it. And that's all thanks to the development of new mathematical theories that these more elusive of nature's pattern are beginning to reveal their secrets.
So that's all for this video. Thank you for watching. Together, let's find peace around the world. Bye-bye!
Switch on the sky and the stars glow for you. Go see the world cause it's all so brand new. Don't close your eyes cause your future's ready to shine. It's just a matter of time before we learn how to fly. Welcome to the rhythm of the night. There's something in the air you can't deny.
Pattern plays an important role.
This numerical pattern was one of the key.
German astronomer Johannes Kepler, in his book The Six Concerns Snowflakes,